Excuse me. This one we were covering, right? Okay.
Yeah, the I think account one.
Yeah, this one, yeah.
Mhm.
Uh, okay, so yeah, yeah. So I was explaining this withdraw method, right? Last time.
Uh-huh.
So
Yeah.
account has one balance like 5,000, and it will be checking the
Mhm.
balance, checking the diff. If it is greater than zero, then only it will withdraw it, update the same amount, else it will say insufficient amount balance. And there's a withdraw class, which is a thread, and which has an account as an object. Using this account only,
Mhm.
uh, the thread will call that withdraw method. So this account object they will be using to withdraw this, because this withdraw method is a part of account class. So account class is there inside this thread, and using this thread, account thread, we are going to withdraw the 100 rupees amount using this. So it will keep doing that, and this is our main application where I'm creating 50 threads. 1 to 50 is there, and I'm
Mhm.
creating withdraw. Withdraw equals to new withdraw, that is a thread, or you can write like this as well. But I think, yeah, here it will keep. No, there is a method. Okay, so this withdraw is nothing but a type of thread, because it is extending thread, and we are
Mhm.
setting the account object using. We have created one common account. So if you can see this account object, okay, so this
Okay.
is a common account for everyone. So it's like there are 50 account holders. Okay, just like you have joint account, like two people get bank balance and account, and they both can withdraw the money. So it's just like joint account, just think about that. And there are 50 total types of account. 50 people are there who is holding the same account. So what I'm doing is that I'm creating an object of account, and this account object I am passing it to the withdrawer. So every time a new thread gets created, I am setting the same account object to everyone. Correct?
Mhm.
So see, with
Yeah.
thread dot account, so that means with this value, right, I am setting the account value with here,
Mhm.
with this account whatever I am creating, and then I am saying thread dot start, and then just setting the name as account holder, this one account holder 1 2 3 4, like this. Okay,
Okay.
so
Yeah.
let's see the behavior of what is going. So
Insufficient balance.
now 1 second, we want to, let's make it 5. So 5 people are there, right? So 500 should be withdrawn.
Mhm.
So
Yeah.
balance would be this much, right? 44,500. Correct?
Mhm. Yeah.
So what is problem happening here? If you see, the balance at the end is 4,600. Again,
Mhm.
I know this time it is correct.
Mhm.
4,500, 4,500, 4,600 again, 4,600.
Mhm.
So if you see that, see again 4,600 is coming. So if you see this output, like at the end, my balance should be, every time my balance should be 4,500 only. If I withdraw 10 times, so 10 times
Mm-hmm.
if I'm withdrawing, so how much it should be withdrawing? 100,000.
Should be 1,000.
So my balance should be 4,000, correct? So every time if I
Mm-hmm.
run,
Yeah.
balance should be 4,000. See, 4,200 now,
Mm-hmm. Yeah.
4,900. Does this mean that it has withdrawn only once? So,
No.
this, I'll do one thing just to make sure that we are running 10 times. Here, yeah, I'm printing only, yeah. So now balance is okay. So this is now balance only. I mean withdrawal and then the balance is 4,900. So this is totally wrong. I mean see 4,100, 4,500. Sometimes it is giving me correct. See this time it is correct. This time it is
Mm-hmm.
correct. This time it is correct. This time it is correct. Again wrong. Again correct. So this will see again wrong. Again wrong. So what is happening here? Some problem is happening, right? I mean because if I doing everything correctly, right? I mean, I'm creating 10 threads and I'm creating the 10 threads and setting the account object to that, starting it. So once I start, one by one thread will go into this run method and it will withdraw 100 rupees. Now again, the
Mm-hmm.
second thread will come, it will withdraw, and everyone will go and withdraw the money. So what exactly is happening here is one suppose one thread has come. The problem how it is happening that I'll tell you. Uh,
Mm-hmm.
One thread has come and it is calling the run method and account withdraw 100 rupees. So this method will called 100 rupees, right? With 100,
Mm-hmm.
right? The first time think about the first scenario only. So int 100 has come and int diff it has calculated. So my diff is 5,000 minus 100, that is 4,900. So my diff is now 4,900, right?
Yeah.
Okay, and
Mm-hmm.
then uh, this diff is 4,900 is greater than 0, so it will do
Mm-hmm.
the balance and balance minus amount. So now balance is
Amount.
4,900, right? So it will print
Yeah.
now balance is 4,900. So this is perfectly
Mm-hmm.
fine. Second thread will come and do this. Just assume that your balance is now left with only 100 rupees. How this balance can go negative, I'm telling you, you can see that. So
Mm-hmm.
your balance is now negative, sorry, 100 rupees, and
Okay.
first thread, suppose one thread has come and it called this withdraw method. So withdraw int amount. So withdraw int amount it has called, and then it is telling that okay, diff is 100 minus 100. Okay, I'm making this greater than 0, so let's make it greater than 0. Greater than equal to 0 it should be.
Yeah.
So my balance is 100 and amount is 100. So the
Mm-hmm.
diff is 0, right? So I'm saying
Yeah.
okay, diff is greater than or equal to 0. This is true. So my thread has reached here. The first thread, okay, and was removed by thread scheduler at this point of time. So before it could execute this one,
Mm-hmm.
okay, it was removed by the
Mm-hmm.
thread scheduler. So the
Yeah.
first thread, it remember that I had done the work till here. So next time I have
Mm-hmm.
to start from here. Okay,
Yeah.
I have to start from here. And the second thread will come. Now second thread will come. It will say withdraw int amount, and as the first thread did not, update the balance with the latest value because it didn't execute this line only, right? before it could have
yeah,
updated the balance, it was removed from the uh, third scheduler. So this the second thread will come, it will calculate the diff, it will say okay it's a 0, so diff greater than equal to 0, so it will come here, and balance equals to balance minus amount it will do. So now my balance is 0 now. Okay, so balance is 0,
mm-hmm,
it will say okay withdrew amount, and now balance is 0 by thread 2, and it will come out of it perfectly fine. Now the first thread got the chance. So
yeah,
first thread will think, okay, I had done this work till now here, right? So I
mm-hmm,
don't need to do all these operations again. So I'll start from here, and
yeah,
the balance is 0 now. So 0 minus 100, so it balance will be minus 100,
-100,
right?
yeah,
So withdrew
mm-hmm,
amount, and now balance is minus 100, which is totally incorrect, and that's why it will throw exceptions. Right now it is not throwing exception because we have very less number of threads. So I'll do one
mm-hmm,
thing, I'll create 100 threads and see if thread throwing exception or not. I need to wait for some time, so we'll do one thing. Yeah, now I think it will take a little bit time, so
insufficient balance,
it should throw exception because uh,
uh-huh,
see, insufficient balance is okay because if diff is not greater than, it is telling insufficient. I want this one, that balance should go negative, what I explained, right? So
yeah,
I want to see that. So let's see, make it 1000 threads. Okay.
yeah, we are getting all the remaining insufficient balance, right?
But we should get
After,
exception because I'm throwing one.
yeah,
This one I'm throwing this. This is my custom exception. Remember, I taught you this
yeah,
negative
uh-huh,
exceptions, and it should say that balance cannot be negative. Current balance is something negative. It should say. So
yeah,
I want to see that. So wait, let me increase the sleeping time to this, and have I think 50 is also enough. So
mhm.
it should come. See. Going to withdraw money from account 100. Oh, change the balance to 100 rupees. So that's the problem.
Yeah,
Now to withdraw somewhere it will come negative. Let's run it again. So the balance is
mm,
see, inconsistency is there because see balance is 0, and then again
yeah,
getting that it's a 200, but I want
mm-hmm,
negative. Let me check. I think I put this greater than okay. through. I think we have to. My processor is damn fast. That's why it's not doing this. Otherwise, it should have.
Uh-huh.
Yeah, 5,000. One got posted doctor. So let me see one thing. What value I had given last time was 50 thread and 5,000 balance. And
Mm-hmm.
it was coming, right? It depends on processor also. If it is very fast, right, it will not take much time. So if it should go, sometime it should go. Check 50 thread is there. Am I handling this exception or what? No, right?
Mm-hmm.
Let me remove this if explanation. Why every time balance is 500 only it is showing? Problem. Every time balance is showing
It's 500, yeah.
5,
It's not decreasing.
withdrew amount 500 and now balance. Why it is withdrawing 500? Okay, I had given that 500. Okay.
Mm-hmm.
Exception why it is not. It comes eventually to if you try. I think if you will try in your system, right? It might come. There will be some situation where
Yeah, okay.
okay where it will come. I think last time when I was doing it was coming.
Mm-hmm.
You see, it's totally unpredictable, right? That
Yeah.
situation can occur sometime, and it cannot
Mm-hmm.
occur for
Okay.
2,000 times also. So if you try sometime, anyhow, the problem is coming here is that the value is not correct. So if I like 100, I am withdrawing 100, and I have 50 threads. So 50 into 100, that is the 5,000, right? So my balance,
Yeah.
if I I'm making 10 threads only, so 1,000. So my every time I run it, my account balance must be 4,000, right? Every time 4,000.
Mm-hmm.
But if you see 4,100, 4,300, 4,000, so 4,200. I want to fix this, right? This is a problem, correct? If I have
Yeah, yeah.
10 account holders and all 10 account holders are withdrawing 100 rupees each, my bank account balance should show 4,000 instead of this unpredictable behavior or it can go to negative also. I don't know why it is not going, because maybe this processor is very fast, so it is not going to that situation. Okay,
Hmm.
so if you try
Yeah, okay.
4 5 times, I think it will come. Okay, that negative value will also come. I'll send you this program, you can try it on. Okay, so
Uh-huh.
we need to resolve this problem that my balance should be correct every time, and you know why this problem is coming, right? So this is the same problem, because of that it is happening, same as this one. So it should be something like, the first thread, when it has come and the balance was 5,000, and that guy has come here, the first thread, and it had checked it, right? So this checking is done, and then remove this one here also. Yeah, the discrepancy, how this discrepancy is happening. Okay, so the
Mm-hmm.
first thread has come and the balance was 5,000, correct, the first time, and it is
Yeah.
showing 100 rupees. So it came here, it did this diff, it saw that diff is greater than 0, it reduced the balance, it subtracted the balance. Now my balance is 4,900. Okay, and
Yeah.
before it could have printed this, it was removed from the thread scheduler. So now my
Mm-hmm.
balance is 4,900, right?
Mm-hmm.
And
Yeah.
second thread will come, and as it didn't even took that amount, it will think, okay, now balance is 4,900, so subtract from it. Okay, so it will be
Mm-hmm.
4,800. And that guy,
Okay.
the first thread which has come, he has simply subtracted this but did not update this balance to this balance.
Mm-hmm.
So it will think, okay, now my balance is 5,000, so I reduced
Mm-hmm.
1,000, so let's update it with 4,900. Now the two withdrawer has
Okay.
already withdrawn 200 rupees, but still the amount is 4,900, which is
Mm-hmm.
incorrect. So this is how the discrepancy is happening. Okay,
Okay. Yeah.
just if you see here, see, withdrew 100 rupees and balance is 4,800. That is incorrect only, right? Because this is
Yeah.
the first thread which has withdrawn the money, and this guy is
Mm-hmm.
4,900. It should be 4,900, right?
Yeah.
And if you see here, it is showing at 4,900 balance. How could it be?
Mm-hmm.
See, before that it is showing 4,800, then 600, then 4,700, then 4,400, then 4,900. Right? This is totally
Okay.
wrong, correct? So
Mm-hmm. Yeah.
in order to avoid this kind of situation, that one thread has access till this here, and came went back, and came back by again, by that time you see it changed the value. So we need to do some kind of synchronization, that is, only one thread can work at this at a time. Okay, so to do that,
Mm-hmm.
there is one method called synchronize method. So if you put this synchronize here, public synchronized and void, so but this synchronized, what it does is that it locks this section, this entire section. Okay, this
Mm-hmm.
kind of section is called the critical section. This section will be locked by one thread, and until and unless that thread completes this, the
Mm-hmm.
other thread will not do anything on these areas. So uh, just see that every time it should come 4,000. Now if you run, it should be 4,000 every time, it will be
Yeah.
4,000.
4,000.
Yeah, and if you see the
Mm-hmm.
order, see, first withdrawal will make it what, 4,900, second 800, third withdrawal.
4,800.
So it will be perfectly in order. It can never ever be like that.
Uh-huh.
Okay. So how it is
Okay.
happening is that,
But the account holders numbers are jumbled, right?
yeah,
So
it
is
will
it fine?
be. I am not, no, I will never be sure that first thread will complete first. That I told
Mm-hmm.
you previously also, right? See, that will never change. I mean,
Yeah.
but
Yeah.
it will never, like, if one thread is working on it, then the second thread will also come and
Okay.
remove the first one and get into place. No, until and unless one thread completes that
Mm-hmm.
section, it will never come out from that section. Okay, so this is how
Okay.
it happens. I'll
Uh-huh.
tell you. The first thread which has come, and this synchronization, if it is there, that means it will lock this method. Which method? Withdraw method. Okay.
Withdraw method.
Yeah, so
Uh-huh.
it will say the thread 1, and suppose thread 1's name is T1. So T1 will lock this section. Okay, with a key. He will enter into the, suppose this is my method room, okay? So he will
Mm-hmm.
enter into the room with the key, and that key will be provided by the JVM. That because this is a synchronized, it should be, open with a lock only, okay? So the
Okay.
thread T1 enters into this room of doing this, and with the key.
Mm-hmm.
So it enters with that key, and starts doing this diff balance amount, and this diff is coming as 4900. 4900 is greater than 0, and it came here. Now as soon as it came here, suppose thread
Mm-hmm.
scheduler removed him, okay, removed from the
Okay.
this thread schedulers, okay, and it given the chance to the second one, okay. And now keep in
Okay.
mind that the first thread did not finish this work, right? This is still left for him, and he has to finish this, because again the discrepancy will happen, right? So the second thread, when it will
Yeah.
come, it will see there is a synchronized block here, okay. This synchronized keyword is there. That means this
Mm-hmm.
withdraw method is locked. So it will ask JVM to give me the key so that I will enter into this. So JVM will tell that, see, thread T1 was already executing the statement inside this, and it did not
Mm-hmm.
finish its work and was removed from the thread scheduler. So let that thread get back and finish these jobs, then it will return the key to me, then I will give you the key, okay. So
Okay.
thread T2
Mm-hmm.
will be waiting on this withdraw method to get the key to enter inside this. Now when thread scheduler will see that, okay, thread T2 is waiting just because to, no, thread T1 did not return the key because it was not finished his job. So what it will do, it will give the
Mm-hmm.
chance to the thread T1. So now T1 has finished its work till here, and he knows that no one has touched this code before, okay. So it will be still be
Mm-hmm.
5000 only. So it will start from 5000 minus 100, 4900, finish it works, and hand over the key to the JVM. So JVM will say, okay, he got the key, who is waiting? T2 will say, I am waiting. Okay, you get the key. So he got the key T2 and entered into the section. It will say balance. Oh, balance is 4900, right? So 4900 minus 100,
Okay.
that is 4800, and do these works. So this is how it works if you put
Mm-hmm.
synchronized keyword. Is it clear?
Yeah.
So I mean,
So. Mm-hmm.
what exactly is happening here is, it is, kind of impacting the performance as well, because
Mm-hmm.
thread T1 is executing and suddenly was removed from thread T2, sorry, thread scheduler. T2 will
Mm-hmm.
not be able to work until and unless it will be, T1 finishes its works, right? So it's like a waiting. T2 will be keep on waiting until and unless T1, finishes its work.
Mm-hmm.
Correct, no?
Yeah. Yeah.
So this is one way in which you can make this section as a uh, what I say,
So.
synchronized. There is another one
Mm-hmm.
way is that you can. I'll remove this one. This is method level. It is called. You create a public static final object. See all these lockings, right? I mean, I told you this. It will lock the method, right? All these
Mm-hmm.
lockings are done on object level. So object level, if I say it,
Okay.
it means that key I was telling you, right? So the key will be the object, okay. So here,
Mm-hmm.
if I'm not, specifying anything, I'm simply writing synchronized. So the key will be this account object. Why it will be account object? See, withdraw method I am calling on what? I'm calling on
And
account.
the amount. Amount.
This withdraw method is getting
Sorry.
called on
Account.
this object account. So the locking,
Account. Yeah.
yeah, the locking, this method withdraw method locking will happen on this account. So see,
Mm-hmm.
this account is shared by all these threads, right? This is the common across all these threads. I told you this one, right? Because I am
Yeah.
passing this this account, this I have created only one object of account, and I'm passing this account
Mm-hmm.
object to all the threads. So all the 10 threads is holding the same account object, right? So when it is doing
Yeah.
the lock, if you ask me what is that key, So that lock is nothing but that account object. So that account object is same for all these threads. So if I say this withdraw method was locked on that account object by one thread, that means if
Mm-hmm.
second thread will come, it will also try to acquire the lock using the same object, that account object, and it will see that okay, this account object is already locked, right? So I have to wait it.
Mm-hmm.
If you provide different account number every time, this will never work. So I'll just show you here. If I So what I am doing is here, I am not writing synchronized. I want to synchronize this section only. So there is a section block as well where you can
Mm-hmm.
put this code inside this. So this synchronized keyword, so this synchronized keyword has a block. So in this block, whatever is there, it will be logged on this object.
Got.
So what is this object? This is a kind of object only. But see,
Mm-hmm.
suppose I am doing like this. I'll create this object inside this method. I'll create the object every time, okay, and I'll remove.
Mm-hmm.
So right now this will not work. My intention was to make this as a single object, but this time what will happen, whoever calls this withdraw method, okay, that will create a new object. It's like a new object, right? So that new object,
Yeah.
it will try to acquire the lock. It will get the lock. The first thread got the lock and it is working. Second thread will
Mm-hmm.
come, it will create their own object again, and it will try to get the lock. It will say okay, I am able to get the lock, because the previous object lock and the second object previous lock are different, because every time I am creating the new object. Getting my point,
Yeah.
right? So if I
Mm-hmm.
did at this point of time, if I try to say, see, it's 4200, so it's wrong.
Mm-hmm.
It should be 4000. See, 4400, 4000 now, 4100. It's wrong. Still, it is not working, even if I am doing the lock on this. So the problem is
Mm-hmm.
happening if I remove this one and make it common object. So now what I did, the public static final object, and this will be my lock.
Okay.
So now what is this? Now this lock is only one object, correct? And it's a final,
Yeah.
that means it will never change. So it's only one object, and everyone will try to get the lock on the same object. That's the how it will.
But
Yeah.
is it matters if it is public or private?
No, no.
The lock of.
See, private is see why I did private, because why you will be using this lock method to anywhere else?
Uh-huh.
So it's a common standard that you should follow, that if you are using some, this is not necessary at all. I mean, you can remove this perfectly fine, no? But it's good to use the private keyword whenever you need something inside a class only. Do you think that this lock is required anywhere outside? No. So better make
Mm-hmm.
it private. In fact, I would say make this as also private.
Uh-huh.
So why this is giving problem? Oh, I removed this int and then this. So you can make this private
Okay.
also. I mean, it's better to make private, so that you cannot access outside. So
Yeah.
what I was telling is focus on only this thing, that this
Uh-huh.
final, yeah, the final has to be there, because if you're writing final, that means you're telling that this value will never change and nobody can change it. So even if someone tries to do like this, lock equals to
Mm-hmm.
new object, so that cleverly they will do, it will never let you. It will say it cannot, you
Okay.
cannot change the value, it's fixed, okay, and you have to get the lock on that object only. So now if you try every time, it will be 4000. Never ever be for except 4000 anything. Run it 1000 times, it will be the same.
Okay.
So understand the difference of synchronized block. This is called the synchronized block, what I have written, and the
Mm-hmm.
synchronized at method level. Both are same thing, but if you are using synchronize at method level, you have to understand the context of object. In this case, you are understanding how the object is, you are passing the object to this lock. This one, it should
Mm-hmm.
be final. It should be final. You should not be able to change this.
Yeah.
Little bit tricky it is, so try to work around it and practice it. I mean, this requires a lot of practice, this multi-threading, especially this locking concepts. Okay,
Mm-hmm. Yeah. Okay.
any question in this?
No, they were good. No, it is fine.
Yeah, so this is how you should be using the synchronized context in this, and it's a very costly thing what you are using. Synchronized is not a performance friendly thing,
Mm-hmm.
so people tend to avoid this as much as they can, and that's why this synchronization block is there, that whatever the critical section is there, try to use
Mm-hmm.
that only. And suppose here, if I need to print something, doing some other work which does not requires locking or synchronization, right? Why do I need to synchronize this one, right? So I will be keeping outside this one because I know that there is nothing, it is going to hamper my locking, unlocking or anything, right? So
Yeah.
try to think judiciously that where to use this synchronized. So
Mm-hmm.
if you are using at method level, if I write it here synchronized method level, the entire things gets synchronized. Even though this is not required, this also gets synchronized, which I don't want. So it's if someone asks you why they made it method level and section level, this is called the
Mm-hmm.
synchronized statement, and this is called the synchronized method level. So it's always to use this synchronized statement, synchronized block. This is called synchronized block. So it's always to use, it's good to use synchronized block, because whatever you want to lock, you can do on that only. You don't have to lock the entire thing.
Mm-hmm.
It's always good to do that. And also it gives you transparency that on what object you are locking here, correct? So
Mm-hmm.
you
Yeah.
are seeing that synchronized lock is happening, and you can just immediately click on this lock and you can see, okay. And not necessarily this should be the lock, okay. Mostly we put the name as monitor because these objects are called the monitor. So
Mm-hmm.
you can put any name, so don't worry about the name. You can put your name also, and you can, this is just merely a variable which is a constant keeping value, that's all. Keep in mind that only, that is the main criteria. It should never
Mm-hmm.
change. Once it assigned, it should be assigned. So
Yeah.
keep in mind that it's a transparency that you can see that I am locking in this object. But in case of synchronized method, you are simply putting this synchronized here, and you are not able to understand this synchronization is happening on which object. So in order to find out, you have to go to the caller of this method. So right click on this and call hierarchy. If you see, so this run method is calling this withdraw method. So you need to check on what object you are actually calling this method. So
Mm-hmm.
this account is your monitor or lock. Okay, so now you need
Okay.
to make sure that this account or monitor, this account or whatever the object is, this object has to be atomic. This has to be the same for all the threads. You have to make sure
Mm-hmm.
that. Okay,
Yeah. Yeah. Okay.
otherwise see, if you are not worrying about all this stuff, now see, you have to set it in this main app, create only one object and set the same object to everyone, correct? So
Mm-hmm.
handling these things could be a problem, but it's always good to do like this, create a final object and do the monitoring. So
Mm-hmm.
it's transparent. It's more visible to the developer that what is going on. Okay.
Okay. Mm-hmm.
I'll I'll cover a few more things. There's a
Mm-hmm.
very good example of uh, there is a one famous problem which is called the producer consumer. Uh, so just go through Wikipedia. Uh, the producer-consumer problem, also known as a bounded buffer problem, is a classic example of multi-process synchronization problem. What we are, telling multi-threading. The problem
Mm-hmm.
describes that two processes, the producer and the consumer, there will be two different application when share a common fixed size buffer used as a queue. Okay, the producer's job
Mm-hmm.
is to generate the piece of data and put into the buffer and start again putting that again. At the same time, the consumer is consuming the data, that is removing it from the buffer one piece at a time. And the problem is to make sure that the producer will not try to add data into the buffer even if it's a full, and the consumer won't try to remove the data from any empty buffer. So I will just tell you in the single line what exactly
Mm-hmm.
this problem is and how we need to solve it. Suppose we have a queue. You understand the concept of queue, right? So
Mm-hmm. First in, first out, right?
correct. So it's a first in, first out. I have a queue and
Mm-hmm.
there is two application. One is producer and one is two produce application means two program is there. Okay, this thing like that.
Yeah.
I have two programs. So one is producer and this is, sorry, this would be C, consumer. Okay, now producer's work is to
Mm-hmm.
create one element and put inside the queue. So it will do put one, then two, then three, and then four, and so on. And
Mm-hmm.
consumer's work is to remove the element from here, consume the element. So it will consume one, then it will consume two, then it will remove three, then it will remove four, and process it. Does whatever, I don't know. Okay, but
Mm-hmm.
they both will be working on the same queue, right? I mean, to I want to write an application where I will keep sending the messages, and I want this consumer to get the message from here, a common platform. So this queue is a
Yeah.
common platform from where the producer has to take the element from, put the element here, and consumer has to, one second, just
Yeah. Yeah. Okay.
hello, hello. So what I was your question, okay, fine. So the problem, what problem will be coming is that one second, where is that? So whatever the queue was there, so this producer and the consumer. So just see the queue, right? This will have a fixed size. I mean fixed length. Okay,
Yeah.
like it will
Mm-hmm.
be, suppose it can handle 20 messages. We cannot make it infinite or something, because it might overflow or something, and I will not have the size also. So
Okay.
my process, producer and consumer has to be a fairly, what I want. I mean, what generally we want is like, okay, as soon as the producer should produce, consumer should consume. Correct? It should never
Mm-hmm.
be like,
Yeah.
okay, producer keeps on producing and consumer is taking one element, after 10 second or 20 second and making it very slow. So the problem, what we are generalizing try to say is that, suppose my consumer is slow, I don't know, this consumer is written by some bad coder, or suppose this consumer takes a little bit more longer time than the processor producer. Like producer's work is to simply process some string, okay, and this
Uh-huh.
consumers is to do changes to uppercase, convert all the alphabets to this one, that one, and suppose it does so many operations, right? So it is
Mm-hmm.
taking a little bit longer time than the producer. So what will happen
Okay.
here, the problem what will happen, this queue has a fixed length size as a 20. So this
Mm-hmm.
producer will keep on producing the element like 1 2 3 4 5 and so on. It will reach to 20, and
Okay.
this consumer is still processing the first element only, right? So
Mm-hmm.
this producer will not know that okay, the queue has been filled, and the consumer is consuming the elements. So this producer does not know that queue is full. It will, what it will do is that it'll keep on pushing the element. It will keep on producing it. It will never stop for that consumer. Hey consumer, you consume the elements and then let me know so that I will produce it again. This
Mm-hmm.
let me know thing is not there. There is no communication happening between producer and consumer right now. Okay, so the
Okay.
producer is not understanding that okay, no, consumer is not able to consume the elements, so let's wait for it. Once it consumes, then I will start consuming that. So suppose queue is full, 1 to 20 is full, and producer is seeing that okay, queue is full, okay,
Mm-hmm.
and suppose it is waiting. So and
Mm-hmm.
the consumer starts consuming that, okay, so it consumed 1 2 3, and producer is still waiting that queue is full because nobody has told him that the consumer started consuming the data and you need to start producing it again. So this will be infinitely waiting.
Mm-hmm.
This producer will keep on waiting that okay, queue is full, because it is seeing the last element. It is not seeing
Yeah.
that from here this guy has started consuming the elements, right? So this
Mm-hmm.
is one problem from producer side. And just reverse the case, that suppose producer is very slow, okay, it is producing the
Okay.
element very slowly, and consumer is very fast, okay. So
Mm-hmm.
producer suppose produced 1 2 and 3, and consumer within a second it consumed all three, okay, and then
Okay.
it's seeing that queue is empty. Consumer is seeing that queue is empty, so it will wait, that okay, once this queue, the once the producer produces something, I'll consume it for that. But nobody is
Mm-hmm.
there to tell the consumer that okay, hey, some new element has come, right? Because the
Okay.
producer will silently keep into this one, this queue, and will keep in this one also, and it will keep doing his work. But the consumer will never know that the this queue has someone has put the element, because there is no listener or something like that. So
Mm-hmm.
this problem you need to resolve, and this problem is called the producer consumer problem. Okay, read
Okay.
more about
Mm-hmm.
the Wikipedia. I think you can read it. So I
Okay.
have written one solution for this. There could be many solutions, it's not like that. It's what
Mm-hmm.
I had written, that I will be showing you right now. So
Okay.
how we can solve this problem. What exactly we can do is that there is a two method known as wait
Mm-hmm.
and notify. Okay, so
Mm-hmm.
how these two this is called the intercommunication, inter-threaded communication. The two threads can communicate using these two methods, wait and notify. And there is one more as notify all. I will talk about this later. So this wait
Okay.
and notify method is the just like kind of tagging or pinching to each other. Something happens, I'll pinch you, okay, now see started doing this, and the other thread will wake up, okay, so you are started producing, let's go and consume it. So it's just like that only, kind of tagging or kind of pinching to each other or poking to each other, okay, let's start doing something. So I'll tell you how exactly this works in so this is my queue.
Mm-hmm.
and my producer thread pt, I'll write pt as producer thread and ct as a consumer thread. Now producer will produce 1 2 3, and suppose first case I am taking where producer is very fast and consumer is very slow, the first scenario. Okay,
Okay.
so this is fast and this guy is very slow to consume. So what is going to be eventually happen, that queue will be full,
Full,
right?
yeah.
So 1 2 3 4 5 6, suppose my queue length is I am putting as a 7. So 1 2 3 4
Okay.
5 6 7, this many of elements can put inside this queue. So this is my queue. Okay, now the producer suppose produced one element very fast, consumer is consuming this element. Okay, it remove this one. By that time it will consume the second element, this consumer. It produced 2, it produced 3, then 4. Very fast, it is very fast. So 6 and then the 7, and it is saying that queue is full.
Yeah.
Queue is full.
Full.
So what this guy will do, I'm solving this problem, that's why I'm telling you. So this producer thread, what it will do is will call a method pt. This thread will call wait. It is waiting, right? It is what it is waiting for, producer?
Producer is waiting for
This guy to
you can say,
consume the element, right?
yeah, yeah.
Right. So as soon as it will consume one more element, there will be one space, and he can produce one more element, right? So it
Yeah.
should wait till, so this consumer should tell this guy that okay, you can wait. Sorry, you can now continue. I am going to get the element. I am going to consume the element. So he will do the wait. He will call the wait, but this wait he will call. He has to use some common object or common something to notify this guy, right?
Yeah.
So there has to be some common object, or like a bell. There has to be one bell. Then whenever he is going to wait, so he will tell that, hey, I'm ringing this bell, that means queue is full, so let me know when we are going to consume, you just ring this bell. So this is one object will be common. Okay, this
Okay.
common object will be there, just like that synchronization I am talking. Okay, so
Okay.
this
Yeah.
common should be common between both the producer as well as
Producer
the
and consumer.
consumer. So this will call the wait on this object. So it is calling the wait on this object, and suppose this queue was full, and so what will happen is that whenever this guy will consume the element, it will call the notify. So suppose it consumed one element, it will notify. As soon as this guy notifies here, it will say, oh, okay, so that means this queue has been consumed one element, so let's go and fill this that with that. Okay,
Okay.
so what how we are solving this problem is that even if the queue is full, this pt comes to know that whenever some element is getting removed from there. Okay, so and same thing is same reverse thing. If you think about, the consumer is very fast and producer is very slow, and this queue is suppose empty, and this is waiting on this. Okay, this called the wait, that queue is your empty, let me know whenever you insert an element into the queue. So as soon as it insert the element in the queue, it will notify this guy. It will check that whether queue was empty. It will say, oh, queue was empty, that means that guy must be waiting, so let me notify this guy that okay, I am going to insert the element, insert this. Okay,
Yeah.
so let's see how we can do in the programming. I have written one already, I just because of time. So just think, this is my producer class. Okay,
Okay.
so this producer class implements runnable, that means a thread. Obviously it will be in thread environment, and this this is my shared queue. So just think about like this as a queue. This is my vector. Why I used vector? Remember array list and vector, I told the difference.
Yeah.
Vector
Vector
was
can be
synchronized.
varying, right?
Remember?
The size can be varying.
Yeah, that is okay. Yeah, array list also can be vary, but what was the difference between vector and array list is that vectors,
Uh-huh.
all the methods are synchronized. Remember, I was telling you that I will tell you later what is the difference between that multi-threading concept. So
Yeah,
vectors
yeah.
method is all are synchronized, so it's safe to use in multi-threaded environment. So I have used a vector of integer type. It can hold the integer type only, and I named
Uh-huh.
it as a shared data. I just named this as a just to shared data, or you can put as a shared queue. So this is your queue in which they will keep on putting the data. Okay,
Okay.
and
Uh-huh.
this is the size. I am telling that okay, this is the size of the queue. I mean the maximum size of this can be this one. Okay, now
Okay.
I've written a constructor which will initialize this value shared queue and the data. So this will be initialized in the producer consumer, yeah, producer consumer here. So if you see here, I've created one shared data. I have put the size as 10. That means maximum 10 elements can go inside the queue. I'll make it better 5 to understand better. So 5 elements only can put into the queue. If it is fulfilling 5, that means queue is full. And then I'm creating this producer produced this one, and shared data and size I'm passing it. So I'm passing this object as a common, and this size I'm passing it. Okay, so my
Mm-hmm.
producer, this guy will set this value shared queue and the size with those values. Okay, these
Okay.
these two things. And then I am creating the thread equals new thread, and passing this prod and set name as a producer thread, and I am starting it. So I have
Mm-hmm.
started my producer.
Okay.
Okay, what
Mm-hmm.
it will do if I'll start this start, that means we'll call the run method of producer, right? So if
Yeah.
I've started, what it will do is that it will create the it will suppose I'll put it 100. So 1 to 100 it will run, and it will keep on producing element 1, 2, 3, 4, 5. As soon as it reaches to 5, and if it
Mm-hmm.
is seeing that okay, queue is full, right, it should wait, because
Yeah.
consumer did not start. Suppose consumer starts lately, I have started consumer lately. So
Mm-hmm.
by that time, suppose by this time, suppose this I have started this one, and by that time these things executed, my producer has already produced 5 elements, and the size is, what is the size is only 5, right? So it has to wait,
Okay.
correct? So if I call this
Mm-hmm. Yeah.
produce method with one value got called, two value will called. So it will, what it will check is that shared dot size if is equal to size. That means the
Mm-hmm.
queue size, if it reaches to 5, it will do the synchronization on this. It will lock on that, and it will say queue is full, so I am waiting on this.
Okay.
So what it will do is that share dot wait. So share data is the common for consumer as well as the producer. So in consumer
Mm-hmm.
also, let's see. So consumer has shared data. It has int size, and same thing I'm doing, and run. And what it will doing is that consuming, and it calling the consume method. So in consume, what it is doing, that it is checking if it is empty, then only it will wait, else it will remove the data. See, remove the data, and it will notify all the it will notify or notify all, both you can do. It will notify
Mm-hmm.
all those threads who are waiting for this one. So I'll show you how it is little bit, it will tricky. So producer has created, no, it has been created, and consumer has also been created. So just suppose that producer started running. Okay, so producer
Mm-hmm.
started running, and it called this run method. It had produced a value as 1, and the first time the shared size queue is not equal to size, right, because it's 1, correct? So this
Yeah.
will
Yeah.
not get executed. This will get executed, and what we are doing is that we are adding the value to the queue.
Yeah.
correct?
Mm-hmm.
Now after that I am doing the notify all. Why I am doing here? The question is why I am doing this. After putting the element into this, I am doing this. Just imagine a case
Mm-hmm.
that I have created this producer and consumer. Just imagine that there could be a chance that producer did not start. Okay, it did not
Uh-huh.
start the run method. The run method, what it started is consumers. Okay, so what we
Uh-huh.
did is consumer dot start. So it will come to consumer, and producer did not produce any element. So queue is what? Queue is empty. Okay,
Empty.
so
Yeah.
what will do, the consumer will come to this run method, it will try this, and it will call this consumed method will come here, and it will
Mm-hmm.
check while shared data is empty. What will come? It will come true, right?
Mm-hmm.
Because
Yeah.
producer did not produce any element till now. So what it will
Mm-hmm.
do is that it will lock it and it will come here and share dot wait. What it will do is that it will
Mm-hmm.
wait for someone to notify that element got added in the queue. Okay, so it will
Okay.
wait on shared data that okay, wait for someone. So I am waiting here because queue is empty, I cannot consume anything. So let
Mm-hmm.
me know, it will be waiting here. So let me know if someone adding some element, and how it will let you know using this notify or
Notify.
notify all. Okay, so using
Mm-hmm.
these, either these two, this will get wake. So till that time it will be waiting. So this thread, the consumer thread, is in waiting state. Okay, it is
Mm-hmm.
waiting. Now suppose the producer has come. Okay, now producer
Okay.
got the chance and it is running. It came here into value, it took into value. It is saying that share
Mm-hmm.
data is full size. It will say no, it will not execute this one. It will come here and share data dot add. It will do the add. It will add one value, and it will think that okay, there could be a chance that someone is waiting on this queue, that okay, if there is no element then I have to wait. So let me wake those up guys. Okay, so
Mm-hmm.
waking up those threads who are waiting on the queue. So who is waking, whom it will wake up? No. So as soon as it will
The
call this notify all, this guy
mm-hmm.
will think, he was waiting. He'll say, oh, let's get it consumed. Okay. So it will
Mm-hmm.
execute this and it will consume the data.
Yeah.
Now think about the reverse case. Okay. So
Mm-hmm.
producer has kept on producing before the consumer started. Okay, and
Mm-hmm.
producer kept on producing, and finally it reached to this size. So shared data dot size it reached, that means it has filled all 5 elements. Then what it will do is that it will wait, that queue is full, so I am waiting. So it is waiting here, shared data dot wait. Okay, now this
Okay.
guy is waiting here, right,
Mm-hmm.
to produce more elements, because queue is full, it cannot produce anymore, it is waiting. Now suppose the thread has started, this consumer thread. So
Mm-hmm. Yeah.
this consumer will call here, it will say this is not empty, so this will not execute this one at all because queue is not empty. It will come here, it will notify everyone that I am going to consume the element. So who is waiting here? Producer. For what? To someone to consume the element so that it can produce more. And who is notifying? Consumer. What it is
Consumer.
notifying, that okay, I am going to remove element, so I am notifying you that okay, I am going to remove it, so you get it started.
Uh-huh.
So let's see the output. Yeah, so starting,
Mm-hmm.
see, the first thing has happened is starting consumer. Now the same thing I was explaining you before. Even
Mm-hmm.
if see, I what I did this, I started producer first. Okay, but there is no
Yeah.
guarantee that producer will be starting first, right? So
Mm-hmm.
starting consumer has come first. okay, and then produced 1 2 3 4 5, and then I am seeing the queue is full, so waiting, right? And
Yeah.
then it is getting consumed. As soon as it
Uh-huh.
consumed one element, this guy got the notification I produced one element,
Yeah.
right? Again
Uh-huh.
it is saying that okay, fully it is full, so when let me know when you consumed. It consumed one element, it produced one. In this case, if you can see, producer is very fast, because who,
Yeah.
as soon as it is consuming, it is producing, consuming, it is producing.
Mm-hmm.
So this is like, constant, see.
Yeah.
Okay, and
Uh-huh.
let me just tweak code. We'll wait this guy to produce. ah,
Mm,
I'll just do a thread dot sleep, so this will be halt for some time.
okay.
So it's producing, queue is full, waiting. Consumer is still slow. Yeah, see here, this is what I
Uh-huh.
wanted. I wanted this queue is empty. That means
Yeah.
consumer was very slow, okay, and it
Uh-huh.
consumed all these elements, and it is waiting for producer to produce more element, because I made producer very slow, okay.
Mm-hmm.
It is
Yeah.
producing one element at 1 second, but consumer is fast here, okay. So see
Yeah.
here, I'll run it again. So see, producer produced 1, 2, 3, 4, 5 it
Mm-hmm.
produced. It is saying queue is full. The consumer consumed 5 element. It is saying queue is empty. Then the producer again producing. See, consumer is consumed empty. Now producer again produce, and see it will
Mm-hmm.
keep on going. Okay. So
Yeah.
this is how it happens. If suppose if we were never using this synchronize this wait and notify, once this
Mm-hmm.
queue is empty or queue is full, it will not proceed further, because nobody is there to tell them that okay, new element has added,
Mm-hmm.
right?
Yeah.
So see,
Uh-huh.
if I remove this wait and notify mechanism, this wait and notify, it will not work, because nobody will tell them okay, new element got added or removed or something, okay.
Mm-hmm. Yeah.
So just go through. This is a little bit challenging, to understand that.
Yeah. I
You
had
have to
to.
understand the behavior. It's okay if you understood a little bit also. Okay.
Mm-hmm.
So just
Yeah.
go through the program, run it, understand end-to-end programs. Go through it, run it. So what will
Mm-hmm.
happen that you will come with the problems. I mean, why it is so, why it is not so. So go through it, and if you have any question, we can cover in next class. Okay.
Okay. Yeah. Okay.
So only one thing is left in multi-threading is a thread pool. I'll cover in next
Mm-hmm.
session, but make sure
Yeah.
that you
Okay.
go through this so that come up with the questions. We can cover it. Okay.
Yeah. Okay. Okay.
Yeah.
Yeah.
Fine then. And closing this session for today. Okay.
Yeah. Okay.
Yeah. Fine. Okay.